Hi, everybody. My name is Eric Gaze. I direct the Quantitative Reasoning program at Bowdoin College, a small liberal arts school located in Maine. And today I'll be talking to you about how to use Excel in your class, or really any spreadsheet in your class, to more effectively engage your students with real-world data and teach them what I consider to be authentic problem solving. So I'm going to first motivate with a PowerPoint presentation why quantitative reasoning is important and how spreadsheets help our students become better critical thinkers and develop their algebraic reasoning skills. And from there, I'll actually switch to examples of Excel that I use in my class and show you how you can build some for your class as well. So I will go ahead and share my screen at this point. And we can begin our presentation. So again, I firmly believe that spreadsheets are a great way to engage your students in a mathematics classroom. So first, we'll talk a little bit about why quantitative reasoning is so important, and then how we can embed spreadsheets into such a class and give you some examples. So consider this statistic: 87% of US adults cannot read or write with numbers. They're quantitatively illiterate, but the fact that we finish that sentence with numbers should not in any way diminish the impact of it. To be quantitatively illiterate in today's data-driven society is absolutely as debilitating as being illiterate was 50 or 100 years ago. And where does all that data live when we talk about a data-driven society? The data lives in a spreadsheet. So as educators, I think it's incumbent upon us to teach our students how to use this most basic fundamental tool for dealing with data. That statistic comes from the National Assessment of Adult Literacy. And effectively, when we talk about quantitative illiteracy, we're talking about proportional reasoning. In other words, the bar is not raised very high in terms of what we're asking our students to be able to do in terms of quantitative reasoning. Only 13% of US adults can actually calculate annual for monthly costs or determine flooring units per square foot. And so one of the things that we want to think about when we're using spreadsheets is how do we develop our students' proportional reasoning skills alongside using spreadsheets or Excel in our classroom. So let me get back here. Even the experts struggle a little bit with quantitative reasoning. These two graphs look very similar. The first one, this one on the left, is coming from The Economist, and it's ostensibly showing Russian defense spending climbing to $70 billion over this period, while European NATO defense spending has dropped to 265. Like, what in the world is going on here? Sort of exactly the same thing is happening with this graphic from McKinsey company talking about energy consumption and the share of electricity that's making up energy consumption. We can see down here that electricity is only making up 23%, and yet the blue line representing electricity is at the end more than double all the other fuels. So exactly the same, if you want to say, trick is being used to create these graphs. But our students aren't equipped to actually read these graphs. And so I think if we want our students to be able to effectively communicate with numbers, to be able to take the data that lives in spreadsheets and tell people a story from it, we need to teach them how to build graphs like this, in addition to showing them examples of graphs. So I have my students read articles in class where we encounter graphs. And then we use spreadsheets, and I ask them to make line charts and bar charts like this. These are incredibly sophisticated visuals of quantitative information. And I think all too many faculty think, well, of course our students can read this. Of course they understand percentages. And again, all of the proportional reasoning that really is what's behind creating this graph. So we'll come back to these in a little bit and talk about how they're made. And I'll show you an example of making one ourselves. That National Assessment of Adult Literacy was conducted last in 2003. A more recent assessment of numeracy or quantitative reasoning was conducted in 2013, and US millennials came in dead last out of all these countries from the OECD, Organization for Economic and Cooperative Development. Once again, they're asking proportional reasoning questions. Of more interest for us is they also measured problem solving in technology-rich environments. Many math faculty will say that, oh, traditional math courses develop good problem solving skills, especially using technology, because our students, are using graphing calculators or whatever. We beat Poland this time. I don't think it's anything to brag about, but more importantly, the questions they were asking when they talked about problem solving using technology were questions involving modeling with spreadsheets. So this idea of modeling the world, really, if you think about it, I mean, that's what calculus was developed to do. That's what Newton was trying to do when he developed calculus, was come up with some mathematics that would allow him to model the world around us. And that's what spreadsheets allow us to do. And so we need, again, to just provide sort of a basic entry into using spreadsheets so that students can do more sophisticated modeling. So let's take an example of using spreadsheets, working with data. Data is just a bunch of numbers. So here we have mortality rates per 100,000 people from 1968 on. The years are going down in the rows by demographic group, starting with the over 85 cohort, who of course have the highest mortality rates, all the way down to the below 25 youngest cohort, much smaller mortality rates. We want our students to be able to take data, take a bunch of numbers that look like this, and tell a story with it. Now, of course, one of the dangers of Excel is it's very easy to create a graphic, just highlight everything and you get this line chart. Well, nothing really interesting has been done here. We can see that the over 85 cohort has a much higher mortality rate. It went down from 1968 on, but we can't see anybody else down here, right? They're all washed out at the bottom. So what can we do to our data so that we can more effectively tell a story? Well, we're going to use the same trick as the economist and the McKinsey consulting group. We're going to scale all of the values in the 1968 row to 100, and then proportionally scale the columns using that 100 as the starting point. So every number for 1968 is going to start at 100, create an equal starting point, and then we'll be able to see all of them move together. When we do this, now what we're tracking is change over time rather than the absolute numbers. Okay. In order to do this, in order to transform our raw data into this transformed or proportionally scaled data is very sophisticated. To be able to take the two numbers, these first two numbers, 19,000 and 18,000, and say this is to this as 100 is to X, that's an arithmetic problem, right? And our students love setting up a proportion and cross multiplying. But to be able to enter a formula in Excel that we can fill down and then across, so all of these numbers get transformed together, that's an algebra problem. Okay, and so here's the formula that we would enter. B4 divided by B3. So in this case, we're referring to the data set that's living in columns A, B, C, et cetera. We're taking B4, which is the value in 1969, dividing it by the value above it, cross multiplying by the 100. Remember, we had X over 100. So you get a sense of that arithmetic, the setting up a proportion in this formula. But the cell references that we use, the B4 and the B3, are essentially variables from algebra. So when you're using spreadsheets, you're teaching your students algebraic reasoning in addition to teaching them how to work with data. What the dollar sign is doing is locking the value in the 1968 row, that first value, because we're always going to be comparing to that 100 in the first row when we're setting up our proportion. So the dollar sign locks us in row 3. That's why it's before the number 3 there. Okay, so what happens to our graphic is this turns into this. Right, much more interesting story being told here. Exactly the same thing that the economist and McKinsey Consulting Group were doing with their graphs, starting from the same point, tracking change over time. We can see everybody's mortality rates have been going down since 1968. Then we get this interesting blip for the 25 to 44-year-old demographic. What happened in this country in the late 1980s, early 1990s that caused the mortality of the 25 to 44-year-old age group to spike? That's the AIDS epidemic. I mean, this is a picture of the AIDS epidemic and the effect it had in this country. Okay, there's a nice book called The Intelligence Trap by David Robson, and he asks the question: are smart people good at reasoning correctly? And I have smart in quotation marks here because there actually are 3 different forms of intelligence, but we're used to this analytic intelligence, the sort of the IQ quotient. It's what we typically develop or teach in schools. The SAT test is really about your analytic intelligence. For mathematicians, this would sort of be teaching our students how to run a statistical test. Well, the practical intelligence is equally as important, knowing when to actually run that test. And why you would want to do it is just as important, maybe more important than simply that rote procedural skill of knowing how to do something. Also, practical intelligence allows our students to communicate their results. And again, this goes back to their ability to create those graphics using spreadsheets so that they can effectively communicate that quantitative reasoning, quantitative literacy component that's so important when we're working with data. And the third form of intelligence is this creative intelligence, the ability to question assumptions, the ability to run a what if analysis. What if interest rates had changed? What if the price of fuel goes up? Well, when we model with spreadsheets, that's exactly why businesses use spreadsheets, right? So they can conduct this what if analysis. Those last two forms of intelligence really are heavily emphasized in quantitative reasoning courses. And I would argue that when you use spreadsheets in your own class, you also will be developing those forms of intelligence. Essentially, we want to empower our students, give them the tools to think for themselves, to ask intelligent questions of experts so that they can confront authority confidently. So how do we do this? How do we teach, create a curriculum, teach our students how to think? Well, in the course that I've developed, for me, it's really about infusing ratios and spreadsheets into the entire course, okay? When I create spreadsheets for my class, they look like this. I'm creating a template for my students so that they can know where to type in values, and the instructions are in these text boxes. So I would strongly encourage you to do this as well if you're starting off using spreadsheets in your class. It's going to have a powerful effect on your students. This student of mine actually enjoyed doing math, and she wanted to continue to take more math. It was the first time math made sense to her. What's needed for our students is not that sort of formulaic procedural approach, but a greater understanding of where numbers come from and what they actually convey, right? I mean, we want our students to work with real world data and understand what those numbers mean. And then you have this nice quote about a perfectly correct description of Microsoft Excel is that it is a computer implementation of algebra. So when we teach our students how to use spreadsheets, we are actually developing their algebraic reasoning skills. And the reality is that in the workplace, people use spreadsheets. They don't use graphing calculators. It changes the problems that people in the business world can actually confront. Here's a quote from a student who had an internship with IBM. He's like, we constantly use spreadsheets in QR. So thank you for doing this. Thank you for using spreadsheets in your class. Okay, let's take a look at some of these examples that I promised you would see. So here we have just some data on birth. The actual data table comes from the government. And I have this blog, Thinking Quantitatively, at wordpress.com. If you want to see a lot of different examples of graphics and numerical tables from articles that I use in my class, including quiz questions. But anyways, you have some numbers. Now, I'm showing you this because this is a great way for you to use spreadsheets in your class. Just find an interesting article with some data. And then if you can, usually you can download the data itself, or just in this case, type it in and create a spreadsheet problem for your students like I have here. So they've broken up the mother's age into these different cohorts, 10 to 14 years old, 15 to 19 years old. We've got the total number of births up here and then the number of births for each cohort. And so one interesting question we can ask when we're looking at this data table, they give us the birth rate, right? So how many births per so many women? And again, that how many births per so many women, this is that proportional reasoning we were just talking about. So this is how you can develop proportional reasoning at the same time you're actually developing spreadsheet capabilities for your students. So what the first question we could ask is, okay, using this birth rate, which again, this is what the data table is giving us. It's giving us the raw number of births and then the rate. We need to understand, is this a rate per 100 women, per 100 people, per 1,000 women? So students have to carefully read the data table. And we can see right here that it's rates per 1,000 women. And you can ask them to work backwards now from the number of births and the rate and actually compute the total population, the number of women in that subgroup. So I know that this 2,503 is equal to 0.2 births per 1,000 women aged 10 to 14. And so if we want to actually compute the number of women, this would be 2,503 over the total number of women is equal to 0.2 over 1,000. And again, you're getting this sort of cross multiplication. In the solution, I will double click on the formula, and you can see that if you write this down on paper, and I strongly encourage you to write it down on paper, you get this formula equals B4, which is this value right here, times the 1,000 that was underneath the denominator, divided by F4, the rate over here, right? And so this would solve for the total number of women in that group. So this is a formula that we would enter. I'll go back to the previous page and show you how to enter and fill this formula. So going back to the births page, you go into this cell. When you enter a formula in Excel, you always start with equals. And so this would be equals B4, the actual number of births. And remember what we had to do is multiply by 1,000, multiplication is a star, and then we're going to divide by the rate, the 0.2 over here. So notice I don't have to type in F4, I actually just clicked on the cell F4. And really, once you know how to do this, you're pretty dangerous with Excel. Okay, you can enter a formula, and to compute the number of women in this age group, I would want to enter the same thing again. This would be B5 times 1,000 divided by F5. Well, the beauty of using Excel is we don't have to do that repeated typing in the formula over and over. I click on the cell, and in the lower right-hand corner, there's a fill handle. I click on that fill handle and drag down, and I get that sort of same formula repeated over and over. I went from B4 to B5 all the way down to B11 and F11. And what's happening here is my formula is doing this, it's sort of doing the same thing in terms of spatial references, right? I'm always taking the cell to the left, which is in blue. So this one to the left times 1,000 divided by this one to the right in the column F. Okay, so I'm maintaining that spatial relationship when I fill down, and I get all of those. Now, if you want to make a chart for this, the way that you can actually make a chart, let's say we highlight the ages and the number of births for each of those. So in order to make a chart, you need to highlight the information you're interested in, and then you go to Insert, and you have all of these charts over here. Let's just make a simple column chart, okay? And so you can see, I'll make this a little smaller just to make sure that everybody can see it. So you can see you get your basic column chart. It's that easy to make a chart like this. We could have chosen the pie chart or something else. And again, at this point, your students are off and running. Okay, that's really all they need to know how to do in order to use Excel effectively. You can add titles and do all sorts of aesthetic things. I'm going to go ahead and delete that chart. Let's say we want to know the percentage of births for each of these cohorts out of the total number. Right, this is just one more example of entering a formula and filling. This one, though, when we enter the formula, I want to know this 2503, what percentage is that of the total number, the 3.9 million. So the formula now is B4 divided by B3. I hit enter. Notice it's 0. So one thing that you need to teach your students is how to format your numbers correctly. Right now, you can see this this cell is formatted to display the result as a number. If I click on this drop-down arrow, I get all these different choices in terms of how you want to format the number. I want to format it as a percentage. There's a shortcut. I could have just clicked on the percent symbol. So now I can see that this number of births for 10 to 14-year-olds is only 0.06% of the total number of births. But if I fill down, I immediately get an error. And again, this is with great problem solving, right? Like what just happened? There's algebraic reasoning that has to take place where the student has to think, oh, I want to divide the 229,888, not by the cell before it, but by the 3.9 million. If I double click on my formula, both cell references fill down, but I did not want the B3 to turn into B4. So going back into this original formula, we need to lock the B3. So I always want to refer to B3, so I put a $sign before the 3. If you want, you can also put a $sign before the B, because I can fill right, left also, it's possible. And then the letters would change, A, B, C, D, et cetera, the column headers. So I lock the B3, hit enter, and now I fill my formula down, just go one cell. And you can see when I double click on it, I'm now always dividing by the 3.9 million because that B3 cell has been locked. I can then double click on the fill handle and voila, they all fill out like that. Okay, so again, that's it. That's all you really need to know about using Excel. how to enter a formula, how to fill it, and how to use the dollar signs to make absolute cell references versus the relative ones that will move. Again, I would encourage you to just find some data sets, here the top 15 causes of death, and then create these sort of templates where students know where they have to type their answers in. My instructions are always over here. I do a lot of financial literacy. So here we're looking at creating a spreadsheet tracking the balance for buying a TV. Here's real world government data in terms of the receipts and outlays in current dollars, constant fiscal year dollars, 2005 dollars, and that's percentages of GDP. Your students are overwhelmed. I guarantee you they'll be overwhelmed when they see a spreadsheet like this. There's so many numbers. How can we possibly expect them to be able to work with these numbers when no one has ever used them in a class, right? I mean, they can't know what they haven't been taught. And so you don't have to dig too deep to find data sets. They're all around us. Pick anything of interest to you, and you can quickly create a spreadsheet like this where you're asking students to do some interesting things. And I'll just show you this one, the body mass index problem. Here I'm computing the body mass index. This is Calc 3, right? Functions of two variables, function of height and weight. And you can create some really interesting graphics based on this two-way table, okay? So I'm more than happy to answer any emails if you want to contact me. Good luck using spreadsheets. I hope you have fun. And if you go up here, my email address is egaze@bowdoin.edu. So again, egaze@bowdoin.edu if you have any questions. And I hope you do have fun engaging your students with Excel in your class. So thank you for listening. I will stop sharing right now and end the video.